1 plus a half plus a quarter plus an eighth. Even if it went on forever and ever and ever, would it have a finite sum? The answer is yes, it will, right? We could, in this particular case, work out the sum to infinity. And let's just have a quick think about what that means geometrically to give you an understanding of this. So if I was to draw an area of a square, length area 1, and added to that another area of a half, and then another area of a quarter, and then another area of an eighth, and then a 16th, and then a 1 over 32, and then add to that a 1 over 64, and so on and so on and so on and so on. You can see that we are bounded by 2. And you might think, well, I never quite get there. Yes, you do. You do get there. We sum to infinity. We get an answer. That sum is 2. So under certain conditions, yes, we can add that up. So the question then is, well, what conditions? Well, clearly you'll notice that these terms are getting smaller and smaller and smaller, and that's the point. If they're getting smaller and smaller and smaller, then, well, the ones at the end are going to be hardly relevant at all. They're going to be negligible. And when we have that situation, we can sum. So what does that mean? Well, it means that R has to be less than 1, right? Or I should say the magnitude of R has to be less than 1. So R between -1 and 1. And if we get that condition, then this nice pattern is going to work. Okay, so if that's the case, well, how is this going to affect our formula? And what's a nice formal way of talking about this? Well, if we have the magnitude of R being less than 1, we say that the sequence converges. Okay, so, and again, think about the sequence 2 plus 4 plus 8 plus 16. You can see straight away R is 2 here. It's never going to add to a finite number because the terms on the end are getting bigger and bigger and more massive. So what we're going to say is if we have that R is less than 1, then we converge. But not only that, think about this in our formula. That is going to tend towards 0, isn't it? If we have R being a number that's less than 1, right, a half to the power of 2, a half to the power of 7, right? As soon as we get n tending towards infinity, R to the power of n is going to tend towards 0. So if that's the case, how does that affect our formula? Our original formula is this: U1, 1 minus R to the n over 1 minus R. I've written it that way around. But as n gets bigger and bigger and bigger and bigger and bigger, we go through more and more terms. R to the power of n tends towards 0. So that means that our S, in fact, let's call it S infinity now because we're talking about infinite terms, is just going to get rid of that. We're going to be left with U1 over 1 minus R because the other part of it is negligible. And this is a formula that we can only use when R is between -1 and 1 to sum an infinite geometric series. Okay.